Hello everyone. Through this video we are going to discuss the concepts of section formula for the chapter of 3D geometry. So section formula, there are two types of section formula. First one for internal division, second one for external division. So the formula are like this: let the two given points of the 3D plane be capital P x1 y1 z1 and capital Q x2 y2 z2. Let the point capital R x comma y comma z divide PQ internally in the ratio m:n, then the coordinates of capital R are, we can write like this: mx2 plus nx1 divided by m plus n, then my2 plus ny1 divided by m plus n, then mz2 plus nz1 divided by m plus n. Similarly, if the same points we take for external division, means the same results, if we consider same the same statement if we use for external division, then it will be like this. Suppose if I change this internally term to externally, means if this is written as externally in the ratio m:n, then there will be some changes in this expression. What are these? Means the coordinates will be taking a different form. Like this, means in place of plus, wherever there is plus in this coordinates, we should have to write minus. So that is a change to be observed. mx2 plus minus nx1 divided by m minus n, then my2 my1 divided by m minus n, then mz2 minus nz1 divided by m minus n is the formula for external division. So here in this case, if R is acting as a midpoint, when R is the midpoint of the line segment PQ, then we get what? Coordinates of R are x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. We get this result. Again, after this, another format, what is that? The coordinates of capital R which divide PQ in the ratio k:1 are obtained by taking k is equal to actually m by n, which are, in that case, the coordinates of R will be like this: k x2 plus x1 divided by k plus 1, then k y2 plus y1 divided by k plus 1. Then k z2 plus z1 divided by k plus 1. So these are the formula required for solving the questions of this exercise 12.3. So first question I am picking up, exercise 12.3. The question is actually find the coordinates of the point which divides the line segment joining the points -2, 3, 5 and 1, -4, 6 in the ratio 2:3 internally and 2:3 externally. So here in this case I am writing the solution part directly. Given points are P -2, 3, 5 and Q 1, -4, 6. Let the point capital R divide PQ, first one, internally in the ratio 2:3. Then the coordinates of capital R will be, which formula do we have to use here? Of course this one, the very first formula which I have discussed just now, that is mx2 plus nx1 divided by m plus n. This format we have to follow. my2 plus ny1 divided by m plus n. Actually this is an extension of the portion which we learned in class 10 in the chapter of coordinate geometry section formula. mz2 plus nz1 divided by m plus n. So this formula we are going to use here. So the results will be like this: 2 into 1 plus 3 into -2 divided by 2 plus 3. Then after 2 into -4 plus 3 into 3 divided by 2 plus 3. Here in this case 2 into 6 plus 3 into 5 divided by 2 plus 3. So that is what result we shall get here, ultimately -4 by 5, then after 1 by 5, then after 27 by 5 on simplification. Then after, if we come to the externally part, means second part, externally in the ratio 2:3, then the coordinates of capital R will become, with minus sign we have to proceed. The second formula, that is m x2 minus n x1 divided by m minus n, then m y2 minus n y1 divided by m minus n, and the other one is m z2 minus n z1 divided by m minus n. This formula we have to use here. So what result do I get here? 2 into 1 minus 3 into -2 divided by 2 minus 3, then 2 into -4 minus 3 into 3 divided by 2 minus 3. After that 2 into 6 minus 3 into 5 divided by 2 minus 3. That is, we are going to get 2 plus 6 by -1, then -8 minus 9 by -1, then 12 minus 15 by -1. What result we shall get? So after this it will be minus 8, 17, 3. So this is the answer. After that I shall pick up question number 4. What is given here? Using section formula show that the points A 2 minus 3 4, then B minus 1 2 1, and capital C 0 1 by 3 2 are collinear. So we have to show collinearity here. Means we mean to say that in the same straight line the point A, B are supposed lying, and C, we are to show that C is also lying in this line. For that, what do we have to do? We shall assume that any other point, say let any point capital P divide AB in the ratio K is to 1. Then the coordinates of capital P can be written as, how can it be written? Minus K plus 2. The last formula I am using here means this one. K x2 plus x1 by K plus 1, then K y2 plus y1 divided by K plus 1, K z2 plus z1 divided by K plus 1. So this formula I shall be using here, and ultimately actually P, any point I am taking here, ultimately we shall show that whatever coordinates we are having for P in terms of K will be coinciding with the point C. If it is verified that P coincides with C, then it will be clear that C lies on AB. Then after, twice K minus 3 by K plus 1, then after K plus 4 by K plus 1. So these are the coordinates for the point P. After that, we shall now show that we shall now check that for some value of K, capital P coincides C. That is, let us pick up the x coordinate. We shall consider again the x means coordinates of C are 0 1 by 3 and then after 2. This is point C. So we shall now consider that P is coinciding with C. So of course this x coordinate will be equal to this x coordinate. That means minus K plus 2 by K plus 1 is equal to 0. So we shall be getting minus K plus 2 equals to 0, which will further give us K equals to 2. Now for K equals to 2, we shall assume that, means for K equals to 2, we shall now show that this value will be giving us a result of 1 by 3 and this value will be giving us a result of 2. If it happens, then it will be very clear that P coincides with C, and as soon as it happens, we shall understand that these 3 points A, B, C are collinear. So for K is equal to 2, we get twice K minus 3 by K plus 1 is equal to 2 into 2 minus 3 by 2 plus 1 is equal to 1 by 3. And then what do we get? K plus 4 by k plus 1 is equal to 2 plus 4 by 2 plus 1, and the result comes as 6 by 3, and that is 2. Therefore, so ultimately we see that the required results we are getting here. Therefore C 0, 1 by 3, 2 is the point which divides capital AB internally. How could I say that this is internally? See, when k becomes as a negative result, then the result will be for external division. When k is negative, divides externally. When k is positive, divides internally. Remember this. Internally in the ratio k is to 1. K is to 1 here will be what? 2 is to 1. Hence, A, B, C are collinear. So this is the answer. Next, I'm going to pick up question number 5. So in question number 5, what happens? The question is given that find the coordinates of the points which trisect the line segment joining the points P 4, 2, minus 6 and Q 10, minus 16, 6. So here in this case, given n points of the line segment are capital A 4, 2, minus 6 and capital, this is P and this is Q. Q is 10, minus 16, 6. Now the line segment PQ are trisected by the points R and S such that PR is equal to RS is equal to SQ. How could we say that? See, this is the line segment PQ. In between, I am placing 2 points R and S such that this part is equal to this 3 parts, means all these 3 parts are equal. Now for the point R, what is the ratio of division? Very clearly it is 1:2 because 1 part and after that 2 parts are there. So ratio of division at the point R will be 1:2. And for S, what is that? It is of course 2:1. Why so? Because in front of S there are 2 parts and after S there are 1 part. So with this ratios we have to determine the coordinates of the points of trisection. So for the point capital R, the ratio of division is 1:2. Therefore the coordinates of capital R are, how can we write? 1 into 10 plus, formula for internal division we are using here, 2 into 4, because the points are lying inside the line segment, therefore internal division. So it is 1 plus 2. Then after what comes? 1 into minus 16 plus 2 into 2. Here it is 1 plus 2. Then after 1 into 6 plus 2 into minus 6 divided by 1 plus 2. So results will be like 6 minus 4 minus 2. So this is the answer for coordinates of R. Similarly, for the point capital S, the ratio of division is 2:1. Therefore, the coordinates of S are, in what way can it be written? 2 into 10 plus 1 into 4. Am I right? The reverse case we need to consider here. So it is 2 into 10 plus 1 into 4 divided by 2 plus 1. Then after 2 into minus 16 plus 1 into 2 divided by 2 plus 1. Then after 2 into 6 plus 1 into minus 6 by 2 plus 1. And the values will be like 8 minus 10, 2 on simplification. So these are the answers. With this exercise gets over. The questions of miscellaneous exercise are almost similar to the questions what we have already discussed in these videos of 3D. So accordingly, these sums could be solved. Thank you.